Your job is to make sense of the graphs that you were emailed or emailed a link to, and you need to look at those graphs to figure out just what is going on in Riverwood. You should have this sheet that has got the EPA standards, the graph data, the trends, and compared to the EPA. First thing, you need to look at your graphs and record data for the 2nd September. The month September appears twice, so the September of the year before and the September of the fish kill, which is the second one. You need to write down with units all the graph data that is there. You can either read that off of the graph or you can read that off of the table if you were given a table to read, either or. Whether the graph or the table, you record that data. First thing you need to do. Now, the trends, you then need to compare that data to itself. So a normal trend looks like this, where you have got something that can go up and down, up and down, up and down. I mean, this is water flow, so you have your rainy seasons and your dry seasons. So this is a normal trend. Everything is within the range. Everything is fine. Even pattern, all in range. A high trend, you will see that even though you have your average range, something sticks up. It is out of that range. And not only that, but it is month 29, which on this graph is the second to last dot. And that second to last dot, both in your graphs and in this graph, is the month of the fish kill. So on the month of the fish kill, with this graph, the water temperature would be quite high. That could be a clue as to what killed the fish. So you're going to look for these out of range things for high trends. Low trends, while being within the range, are pattern breakers. See, you will notice that as the up, down, up, suddenly it drops sharply. This here is a low trend on month 28, 1 month before the fish kill or 2 months before what is considered current time. So low data are pattern breakers. They had a pattern and then bam, suddenly they're low. This is low the month before the fish kill, but the fish kill occurred right at the beginning of the month, so that's still very telling. And also, it is important that you check both the month before and the month after the fish kill to see how things affect. That could give you more clues as to what actually killed the fish. Now, you're then going to compare it to the EPA. Now, when it comes to comparing to the EPA, you're going to look at your graph data, and you're going to look at the EPA standards that are right next to it. And you're just going to sit there and say, is it high, okay, or low, or is it just high or okay? Because as far as nitrates, there's not a too low nitrates. Same thing with lead, mercury, arsenic, or pesticides. You don't need any amount of arsenic for the fish to be fine. Arsenic is a poison. So it's either going to be high or it's going to be okay. This here is a huge clue as to what killed the fish. Now, if we look at the EPA thing, we're going to look at cadmium here, cadmium being a heavy metal. If you see, the trend is high 29, okay? The 29th is the highest cadmium has ever been, and it's right there 1 month before, or the second dot before, so this is definitely the fish kill. The EPA says 5 micrograms is harmful, but this says you've just got 2. So the EPA says you need 5, but you don't have anywhere near 5. You don't even have half of that. So this is not the fish killer. It's still within EPA limits, but the fact that it is high could point a clue as to what is actually killing the fish. So you still need to mark that it is a high trend, but that it is okay within the EPA. Then you're going to have something that looks like this or something similar where you'll have your 6 options and you'll have to say which of these options matter. So this is your next thing that you're going to do is, was it toxic chemicals? Was it low oxygen? Was it acids, bases, etc.? And all you do, you either say yes or no, or you color in the boxes. Whatever the paper tells you to do, that's what you want to do. Find which ones match. Look at the data. Does it have high rainfall, high pesticides, high arsenic? Then yes, you have toxic chemicals. So this is a possible cause of the fish kill. You can have more than one cause. So there you go. You then need to identify which causes are most likely to have caused the fish kill. Basically, all the ones that you find, you just list. And then you say why. Why do you think that? If you have 2 different causes, try to say which one you think is more important than the other one. You can say they're equally important. That's completely up to you. Based on the causes, you then need to figure out who is responsible. There are some sources here. There is even more sources given to you within this document where you have this causes of the fish kill. So this goes through each of the causes: toxic molecules, heavy metals, suffocation, gas bubble trauma, pH too low or pH too high. It has all 6 of the ways the fish kill could have happened. It repeats the proof and it talks about the possible sources. It also gives you bonus info here, which can help you determine who is to blame or what really happened. Furthermore, there is another document that has either been shared with you or made available. You'll have a link that's right down here that you can also get to that document, which will give you even more detail than before. And so that will help you determine what killed the fish, who killed the fish, and you also have been supplied a map of Riverwood because geographic location may matter for certain causes of the fish kill.